times 180 divided by 7, which is like 334.286 degrees. But I can look at it and tell that 13 pi over 7 is not quite 2 pi, because 2 pi would be 14 pi over 7. So I know it's between 3 pi over 2, which is the same thing as 270, and 360 degrees. It's going positive. So if I start here, I rotate it around this way. Doesn't really matter how nicely you set it out. And that is theta, which was 13 pi over 7. Somewhere in there. I've got to have it in the right quadrant, which was quadrant 4. That was the first step, was to draw it. Second step, find the measure of the reference angle. So the reference angle would be, I'll do it in orange again, would be, of course, this angle right here. And we can see that that angle is finishing up this circle, right? The red and the orange together make a whole circle. So I could take 2 pi, which is the whole circle, minus 13 pi over 7. Or you could do it in degrees and then have to turn around and change it back into radians, which is okay. So I'm going to make it over 7. So it's 14 pi over 7 minus 13 pi over 7, which leaves us with the reference angle being pi over 7. Now we need positive and negative coterminal angles. Well, before to find coterminal angles, we added or subtracted what? 360, which is a circle. What's a circle in radians? 2 pi. So we add and subtract 2 pi. So to go from pi over 7 to a negative, I would subtract 2 pi, which we already rewrote as 14 pi over 7 earlier. So that's negative 13 pi over 7. And of course, there's always more than one. You know, some people will get an equivalent coterminal angle. It's just 2 pi more away. And then pi over 7 plus 2 pi gives us a positive one. So it's 15 pi over 7. And this is really a good review of what we've already done. This isn't really anything new. Now, on the bottom part, it says for each of the angles, that's there if you still need it. But on the bottom, it says for each of the angles theta described below, determine the quadrant or axis in/on which the terminal side of the angle lies. If no such angle exists, state why. Completely explain your reasoning. The best way to figure these out is to remember one little thing. We start in the first quadrant, and we go just like we count for all the quadrants. The first quadrant is all students take calculus. True, right? So all students take calculus. So what that tells us is which ones are positive. So in the first quadrant, they're all positive. In the second quadrant, since it's S, sine and its reciprocal. So sine and cosecant, those go together. Because they're reciprocals of each other. So what are you supposed to T stands for? Tangent. And what's its reciprocal? Cotangent, yeah. And then this, the C, that's cosine, and its reciprocal? Secant. Good. So this is telling you where they're positive. So this says cosine is negative. So cosine is negative in which quadrants? Yeah. It goes 1, 2, 3, 4. So the first, all and the cosine are positive in the first and the fourth quadrant. So that means they're negative. And I don't know, that's supposed to be a 2. It looks like a 1. There we go. It's negative then in the third and the second quadrant. And then it says tangent is also negative. Where is tangent negative at? Tangent is negative in the other ones, which would be negative here and here. So where do those two overlap? Which quadrant? Which quadrant is it?
The second one.
Second one. So it's saying where's cosine and tangent both negative? They're both negative in this quadrant because only sine is positive in this quadrant. So that's the all students take calculus. When it starts talking about undefined things, then it has to be talking about an axis. So on these, we use a unit circle. Jose, you're getting your steps in today. Thank you. Talked about this slightly last Friday. Okay. All right. So each point on the axes are on the x and y axes, of course. And then this is a unit circle, which means that if you draw it on a grid, it's only going to go up, down, left, right, 1. So this point, I go to the right 1, and don't go up or down at all. So that point is 1, 0. What would this point be? 0, 1. Good. What's this point? Negative 1, 0. And the last point?
0.
Good. Again, one of those days, either, I think it was last Friday, but I'm not sure. We talked about unit circle and circular tangents and whatnot. Let me see if I can go back there and just look at it for a second to show you. Yeah, here it is. So notice that, like for the sine, it's always opposite over hypotenuse. So if I had some point over here, it would be the opposite side over the hypotenuse, which our opposite side here was y. And if it's a unit circle, then the radius is always 1. So this is something that you do need to know. That in a sine, the sine of a unit circle is always y. The cosine of a unit circle is always x. Tangent is y over x, and then the reciprocal of those. I'll go back and show these here. Okay, so sine is the y coordinate on a unit circle. Yes, sir.
Interesting.
You may. Cosine is x, and tangent is y over x. That's for a unit circle. So using this x and y stuff, if tangent is y over x, then what's cotangent? X over y, right? Because tangent and cotangent are reciprocals of each other. They're flipped. So if it's x over y, and it's supposed to be undefined, what makes a fraction undefined? Over 0. If 0 is in the bottom, so that means if y is 0. So where is y 0? On the x-axis. Exactly right. And then it says cosine is less than 0. All right. Cosine we know is x. So where would x be less than 0? On the negative x-axis, yeah. Right? On this side. So this would be on the negative x-axis. Am I completely explaining my reasoning is what I'm doing here? So even though I didn't write it out in word form, you can tell that's what we're doing. All right. And the terminal side of an angle, that letter is the Greek letter alpha. Passes through the points given below. Find the exact value of each of the 6 trig ratios of alpha. So I'm going to draw this out.